Ugly can be on the outside, like leopard print sweaters, but to makers, perhaps the ugliest thing is on the inside, and that's boredom. We never want to be bored. I've built a sweater to help you out with this. The ultimate in ugly sweaters. As I'm sure you've detected, it's the holidays, and I thought we'd get a little festive by making the ugliest sweater possible. And it's going to be a smart sweater, too. Using the Maker 1000, I've connected it to the internet, and it receives pokes by a web page. If the sweater goes too long without seeing a poke, then it gets bored and starts flashing its LEDs faster and faster. I've got a few things up on this screen. Chief among them is this sketch that I've adapted from a tutorial by Vincent Wong on our own site. And he tells us how to use the Maker 1000 with a REST API. You give it a network to connect to, and then you can send it messages from your browser to control it, or to read from sensors. In this case, we're going to be sending it a poke. It uses a library called AREST, and in his tutorial he used version 2.1.1 and made some modifications to it, so I've done the same modifications since the new version is a bit different and I don't want to mess it up. So, we've got LEDs on pin 13. This is just a set of really simple, boring, cheap LEDs. They're like $3.50. It's like $7 for two of these. And they run on 2 coin cells. And I've just spliced a transistor into the ground wire. The power wire goes directly to the LEDs. Then there's the ground wire that comes back, and a switch that can turn them on or off. Whoop. However, I've taken those same switch contacts and hooked them up to the collector and emitter of a transistor. If you want to learn more about that, go check out my last video, which is about transistors. I've shrouded this NPN transistor in heat shrink and hot glue, so it's not going to get messed with, it being a wearable device. And then the base pin gets soldered to pin 13 of the Arduino, and the emitter gets soldered to ground. That way we have a common ground between the LED circuit and the Arduino circuit. The batteries can push power out to the LEDs and receive it back. And at the same time, the Arduino can push data out to the circuit and get it back. That's how I think of it anyway. It's kind of scientifically inaccurate, but we're dealing with a legacy that put power flow backwards. That's a good Wikipedia hole. Anyway, let's plug in this bad boy. And I've already uploaded this, so I'm going to open up the serial monitor. And it's going to attempt to connect to my phone's tethering, for reasons that you'll see in a second. And once it's done that, I'll be able to send it messages directly through the browser. What this sketch says is that I should enable pin 13 as an output for LEDs. And then I've created this variable between, which basically says it's set to a minute, 60,000 milliseconds for a delay. So it starts out at 60,000 milliseconds, i.e. 1 minute. And then each time we loop around, we divide that by 3. And that's how long we're going to wait between pulses, unless we get a poke from the browser. So it'll start flashing faster and faster until it sees a poke again. It's very impatient. And once it receives that poke, it'll reset the delay to a minute again and give me a quick little double flash to acknowledge. Since I've now connected, I've got an IP address on my network, and my computer's on the same network, which is very important because this IP isn't available to the public internet. So everything on our local wireless is going to see the same thing. So it's gotten to the point where the delays are so fast that it appears to just be always on. And what I'm going to do now is poke it. And it gave me that little flash of recognition, and now it's reset to a minute again. So what is the HTML doing here? Let's take a look. This is an extremely simple page. Don't laugh, I stole it from Stack Overflow. But basically I've taken the IP from the Arduino serial monitor here and put it into this HTML page here. And this makes a post request via HTTP, and it sends it this command, LED, with parameter 0. Okay, what does that mean? So in the setup of the Arduino sketch, I've defined LED, or Vincent has defined LED as the public name of this function, LED control, which we've defined later on in the sketch, which is down here. Yeah, and that takes a parameter, which can be 1 or 0, In this case, we set it to 0, but it really doesn't matter because I'm not actually using that here. The original sketch from Vincent has this state variable being assigned the value of that parameter, and it uses that to turn the LEDs on and off. But since mine is really just flashing acknowledgement and resetting this delay, I don't have to worry about that. I also made a simpler version of this page to test that doesn't use that custom function. So if we throw our current IP in here, we can launch this other page, which just gives us an on and off. The future plan for this sweater is to hook it up to the Hackster API, which enables you to check whether there's new projects and what they are and things like that. It's going to basically check periodically to see whether there's a new project, and if so, it'll flash. And also post the link to the serial monitor here. But that's for another day. In the meantime, enjoy this horrific thing. And I hope you have a happy and hacky set of holiday season. I'm sorry. Happy holidays. Happy New Year.